Good day, students. In this script, we're going to be going over how to graph slope or direction fields given a differential equation with an initial condition. I will also show you how to use the TI-89 titanium to generate the graph of the slope or direction field. All right, so let us take a look at the question. There are three parts to it. We are to, first of all, sketch the slope or direction field for the given differential equation and also the particular solution. Okay, we're going to first of all sketch the direction or slope field, and then we'll draw the graph of the particular solution on the generated slope field. And we have to verify the accuracy of um, our sketch using a graphing utility program. So I'll be using the TI-89 titanium here. And then lastly, we have to solve the initial value problem and compare our graphical result with our analytical results to see if our answer does in fact make sense. All right, so the differential equation that we're going to be considering, question number 1, is the initial value problem, dy dx equals negative x over y with the initial condition y sub 0 equals 2. Okay, this is a initial value problem. It's an ordinary differential equation that can be solved by separation of variables. All right, so let's go ahead and graph it first. So to do that, we are going to create a chart using the coordinates of the points provided on our grid. Okay, so let's see. The range is from -2 to 2 on the x, and then for the y, same thing, -2, -1, 1, and then 2. Okay, so I'm going to start organizing my chart by using my x's, and then using with a specific x input, I'm going to list my y's and then move to the next x and list my y's and then go down that way. All right, so let's make our 3-column chart. It's going to comprise of x, y, and dy dx. So let's say that's x, that's y, and then that's dy dx. So down the center. So if you look at the chart I have, for each x that I select, I'll have 5 y's. Okay, so I'm going to do the first group first. So let's say that's for 1, 2, 3, 4, 5 for the first set, and then next set 1, 2, 3, 4, 5. All right, it's long enough. All right, so that's the first line, and then I'm going to make another line, similar length. All right, so that's for the first set, and then I'll replicate that for the other two I have. Make another one here. Just do it 3 times because there are a lot of points we're graphing here. All right, now let's take a look at how I'm going to populate my chart. So for the first set that I have my x and my y and my dy dx. dy dx is negative x over y. So this is actually what we care mostly about because the x and the y coordinates have already been plotted for us. We want to know what the slope of the tangent line looks like at each point. Okay. All right. So for the first set of 5 points, x is constantly -2. So we have -2, -2, -2, -2, -2, 1, 2, 3, 4, 5, -2. And then for that, y goes from -2 all the way up to +2. Okay, so we have -2, -1, 0, 1, 2. All right. Now we shift to the next set of points, orienting them vertically. These are all x equals -1. So 5 of them, 1, 2, 3, 4, 5. And for all 5 of them, y goes from -2 all the way to 2, like before, -2, -1, 0, 1, 2. Okay? All right. And then let's move on to this line right here. At that value, we have xy negative x over y. So we have 0, 5 of them, 1, 2, 3, 4, 5. And then let's put this one there too. The 1, 1, 2, 3, 4, 5. That's for this set. And then for each one, we know that y is ranging from -2 all the way to 2. All right, so -2, -1, 0, 1, 2. So all the coordinates for this point. Same story here. -2, -1, 0, 1, 2. And for the last line is just 2, x, y, and divide the x, which is -x over y. We have 2, 1, 2, 3, 4, 5, and y does the same behavior, -2, -1, 0, 1, 2. All right, so that's the easy part. Now the work is in calculating the value of the slope. It's not that complicated, but it just requires some work. All right, so let's start out with these points right here. All we're doing here is to find the slope is to divide x by y and take the opposite of a result. All right, so let's start with this one. -2 divided by -1 is +1. The opposite of that is -1. If you divide these two, you get +2. The opposite is -2. If you divide these two, it's undefined. If you divide these two, you get +2. I'm sorry, get -2, and the opposite is 2. If you divide these two, you get -1, and the opposite is +1. All right. So if you look at this 5 sets of points outputs we have here, you notice that there's a pattern with the slope. You see how around the undefined slope we have opposites going on. So we have 2, -2, 1, and -1. So the same pattern might manifest itself in the other output, so we can keep track of that. Take advantage of that in swiftly computing our slopes. Okay. All right. So let's take a look at the next set of points right here, which is when x is -1 and y varies from -2 to 0. I mean to 2. So we have divide these two. You have +1/2. The opposite is -1/2. If you divide these two, you have +1. The opposite is -1. If you divide these two, you have undefined. Divide these two. Can you expect what the answer to be? It should be the opposite of these two, right? So divide these two, get -1. The opposite is 1. Divide these two, get -1/2. The opposite is 1/2. All right. Shift our attention here. Oh wait, 0 divided by anything other than 0 is 0. So this is real easy to determine. You have 0, 0, 0, 0, 0. All right. Now here, divide these two. You get -1/2. The opposite is 1/2. If you divide these two, you get -1. The opposite is 1. If you divide these two, you get undefined. But I made a mistake somewhere up here. 0 divided by 0, this is undefined too. So undefined. All right. 1 divided by 1 is 1. Opposite of that is -1. This is -1/2. We do this one here. 2 divided by -2. The opposite of that is +1. 2 divided by -1 is -2. The opposite of that is 2. This is undefined. If you divide these two, you get +2. The opposite of that is 2. Divide these two, you get 1. The opposite of that is -1. All right. So there goes all your slopes. So it's telling you that at each point, these are the slope of the tangent lines. Okay. So when we're graphing the slope or direction field, we're just getting a snapshot of the tangent line at each point. Okay, the more points you have, the more tangent lines you can generate, which is much more like the um, accurate representation of what the slope field looks like. But we don't have eternity to generate all these tangent lines, so we're just going to give you a snapshot. That's what this is. Okay. All right, so let's go ahead and start graphing the points. We're going to start from the bottom left, which is this point right here, and then work our way up. All right, so as we go down this chart, we're going up these points right here, and then we jump to the next one. And also, we want to take full advantage of the symmetry that's happening here. All right. Okay, so let's start with -2. -2, the slope is -1. All right, so let's go ahead and graph that. So it's the tangent line goes through here and it has a slope of -1, which means that you're going to start from this point. You're going to go down 1 and over 1. Okay, negative rise of 1 and run of 1. So that's going to look something like this. But it's just a snapshot, a small portion of the tangent line. Okay, so that's a graph of -1 right there. All right, if you move up, you have a slope of -2. So you're gonna fall down 2 and run 1. All right. So think about a line of slope -2 is gonna look something like this. Just a sketch, not perfect. Something like that. Let's move it up a little bit. So we're just having a shortened tangent line with a slope of -2. So that's what it's gonna look like. All right. Okay, and then if we shift up to the point -2, 0, oh, that's easy. It's undefined. It's a vertical line. Okay, we know what the slope of a vertical line looks like. It's undefined, so we're just gonna have a vertical line here. Okay, and wait a minute, we might as well graph all of them because we know when when y is 0, we have vertical lines, vertical tangent lines everywhere there. So all this we have vertical line there. We weren't given a point here, so let's ignore that. We have a vertical line here, and then we have a vertical line there also. Okay? All right, so we want to take full advantage of any pattern that manifests itself while we're graphing so we can finish the graphing procedure rather quickly. So can you predict what the slope, the tangent lines to the solution will look like in this quadrant? It's simply the opposite of what we already have here, right? So this is -2. The slope here will be 2. So it's basically like this, reflected upwards. So if we want to graph a tangent line with slope 2, it's as though you're rising 2, 1, 2, and you're running 1. So the slope of that line would be 2. So something like this. Well, it's just a snapshot. So that's this line. This tiny tangent line here has a slope of 2. And this one, what slope do you think it's going to have? This has -1, so this slope will be +1. So starting from here, a slope of +1 means you rise 1 and run 1. Okay, so you have a line kind of like this. So sketch it. Just a snapshot is sufficient. All right. Okay, let's shift our attention to this pair of slopes right here from -1 when x is -1 and y is varying from -2 to 2. When x is -1, the slope, -1 to -2, this point right here, the slope is -1/2. So in this case, we are going to fall 1 and run 2. Okay, so that's what the slope of -1/2 is. So fall 1, run 2. So it's going to look something like this. You can put your ruler on this point, and that point, and just draw this portion right here. Okay, so it's going to look something like that. Just a snapshot is sufficient. Something like that. All right. Okay, and then here the slope for -1 right here is -1. Okay, so we're going to fall 1 and run 1. So the line is going to look something like this. So let's make a snapshot of that. So something like that. So the slope of this line is -1. And we know what the slope of these lines will be. It's going to look just like this, but it's reflected in the other way. So this will be +1, as you can see here. This would be +1/2. So +1 is a line with slope 1, rise 1, run 1. Through here, so it's going to look something like this. And then this has a slope of positive 1/2. You rise 1, you run 2. So it's going to look less steep, something like that. It's like a sketch, just a snapshot, tiny piece of the tangent line. Okay, so you see our slope field is generating the pattern. Can you imagine what these slope lines will look like? Well, let's do the center piece first and then we'll look at that. This is real easy because you notice they're all 0. So what is the slope of how does this line with a 0 slope look like? It's a horizontal line, right? So all these are just horizontal lines right here. Horizontal line, horizontal line, horizontal line, and a horizontal line. Okay? All right, now let's take a look at 1. When x is 1, these values of y right here, what will our tangent lines look like? Well, if you compare positive 1 and negative 1, do you see a pattern? There is a pattern. See, negative 1, negative 2, and 1, negative 2, they have opposite slope. Okay? They just simply have opposite slopes of each other. So when a point, if you fix for a particular y value, the slope of the tangent lines have opposite slopes. All right? So if you look at this point right here, let's start with 1, negative 2. What do you think the slope is going to be here? The slope here was negative 1/2. If I do the opposite, it's going to be positive 1/2. And voila, that's what's happening here. So if I simply reflect all the points here, if I take the opposite of all the points here, or just reflect them about the y-axis and graph them here, that will give me these tangent lines. Okay? So I don't need to do any much hard work here. So I want to graph positive 1/2 here, since this is negative 1/2. So it's going to look something like this. So all we need is just a snapshot. So we have our line. Oops, fix that. Have a line looking like this. Where is it again? Okay, there we go. So positive 1/2 is what we're trying to graph through there. It's just a nice little snapshot. All right, and then what will the graph of the slope of the tangent line at the next point look like? Well, we know that this one had a slope of negative 1. What do you think this would be? Positive 1, and that's exactly what it is here. So draw a tangent line, short tangent line with a slope of positive 1. Put your rulers here, lining up these 3 points, and then just draw a snapshot of the tangent line, okay? And then here, what do you think the slope is going to be? The slope here was negative 1. The slope here, this is positive 1. The slope here should be negative 1, and that's what it is, okay? So I will draw a line, tangent line with slope of negative 1 here, aligning these 3 points together as best as I can, just a snapshot. Boom. All right. Now this had a slope of positive 1/2 right here. See that? What do you think this will be? It's going to be the opposite, right? So negative 1/2 is what we're looking at here. So we can line up these points right here in this orientation. All we need is just a snapshot, right? So this is a slope of negative 1/2. Oops, no. Mistake. Yeah, that's it. Yes, negative 1/2 right there. All right, and then following the same pattern, that's exactly what happens here. If I take all these tangent lines and I take the opposite of their slope values, that's what will be my output here. So like negative 2, negative 2 had a slope of what? Negative 1. What do you think 2, negative 2 would have a slope of? 2, negative 2 has the opposite slope. You see all these outputs here have opposite slopes, so let's use the same pattern and draw the tangent lines here too. All right, so we have for this one, this was, what was this one? Negative 1. So this will be positive 1. Just line up these 2 points. Just a snapshot. This was negative 2, so this is going to be positive 2. So for that, we're going to rise 2 and run 1. So just line up these points right here. Something like this. It's just a sketch. Nothing perfect. All right, so that's 0. And then for this one, that one was positive 2. So this is going to be negative 2. Fold 2, run 1. So connect these dots in this orientation right here. So just make a snapshot, something like this. Okay. And the last one was positive 1. So this is going to be negative 1. Okay, so just fall 1, run 1, connecting these 3 points right here, like that. Okay, so there goes your slope field. Now, does this generate, can you see a pattern here? Absolutely, this is a circular pattern, okay? So these are the tangent lines to a circular relation, okay? All right, so that's that. Now we're going to see if our result is in fact correct by making use of a graphing utility. I'm going to be using the TI-89 titanium to generate the slope field for this equation and see if it matches what we have here. Alright, so there goes my calculator. Okay, so first thing you want to know is the syntax for entering the equation into the calculator. Before we do that, we have to go to the mode and adjust our graph menu, okay? The graph option. It's set to function, press the right button, and we want to change it to option 6, which is differential equation. So scroll down to 6, press enter, enter. Now it's set to differential equation. So we'll go to the graphing menu, diamond F1. So this is the menu for entering differential equations. Now for the calculator, x is t and y is y1. Okay, so that's the syntax there. So we're going to enter negative t over y1. So we have negative t. That's the independent variable, as you can see here. That's the independent variable divided by y1. Okay, the dependent variable is y1. Press enter. Um, and we also have to graph the particular solution. Now, I forgot to graph the particular solution, so let's go ahead and include that. All right, so let me graph the particular solution. The differential equation. We're given the initial condition that y0 is equal to 2. Okay, so that's what we're going to use to generate our graph. Okay, so this initial condition y0 equals 2. Let's go ahead and graph that. We have that basically tells us the y-intercept of the solution, the particular solution to this differential equation. All right, so we're going to start from this point right here, and then basically follow the pattern of the slope field. All right, so it's going to look something like this: tangent at that point, and then tangent at this point, like that. Okay, and the other one is basically like a rough sketch, something like this. Okay, let me draw it again. It should look something like a semicircle. Okay, you might wonder, well, why are we just drawing the upper semicircle? So something like this, and then something like this. So if we had more slope fields, then we can basically generate the perfect curve, but we don't have all the slope fields that we need. So this is the particular solution that we're looking at. The reason why we're not drawing the lower semicircle is because that's not a function. If we were given two initial conditions, y0 equals 0 and y sub 0 equals negative 2, this would tell us another y-intercept, which would be down here. And if we draw that, our solution would not be a function. In that case, it would be two separate functions or a relation if combined. So since we were not given this piece right here, the only portion that we can graph is the upper semicircle. All right, y0 is equal to 2. So that's the graph of the solution to this differential equation. This differential equation basically helps us calculate the slope at every point on this curve. All right, let's go back to the calculator business. So remember I told you the syntax is that x is t and then y is y1, so we have it like that. We're also asked to enter the initial condition. We're going to put in 2, enter. So that's the initial condition right there. And then diamond F3 is your graph. All right. That's what it looks like. And there goes your particular solution right there. Just wait for a second. Let it graph. Okay, so you notice that it's shifted to the left somewhat. This is a default window, but we can always adjust the window so that it looks more like what we have here. So I'm going to go to the window menu, which is diamond F2, and I'm going to alter the window, the domain on the X and Y. The domain for the X and the range for the Y. So the domain for the X minimum, how about we go from -2 all the way to 2, right? So that's our domain from -2 to 2. And then our range, the minimum on our y-axis is -2, and our maximum is 2. Enter, enter. All right, and let's go diamond F3 to generate our graph again. Oh, perfect. So this is more like it. And then you see our particular solution right there being generated. If you notice, our graph is somewhat exaggerated in the y direction, it's somewhat compressed in the uh, y-axis, so we can alter this window into a square window. Okay, so we're gonna zoom F2 and make it a little bit more square. Okay, so zoom 5 is a square zoom. It makes the renditions in the x and y directions equal. All right, so let's go ahead and do zoom 5, enter, make it much more like a square, and let's see what we have. Yeah, that looks much better right now. So you adjusted the axis so our displacement in both directions are much more similar, and you have something like that. You see how the slope fields match what we have, our answer, and then also our particular solutions match beautifully too. All right, so we're confident that our result is in fact correct. All right, let's go on to part 3, where we are to solve the initial value problem. All right, so this differential equation is very easy to solve. Part 3, we have dy dx. dy dx equals -x over y. Okay, we're going to go ahead and solve this by separation of variables, because you notice we can easily separate the x's and the y's by multiplying both sides by y and dx. Okay, if I multiply both sides by y and dx, I'm going to end up with, let's go ahead and do that. If I multiply this side by y dx and multiply that side by y dx, what happens is that these y's cancel out on the right, and this dx is cancelled out on the left, and you have this nice little equation, y dy equals -x dx. Okay, so if you can separate the variables in this nature, then you can solve the differential equation by separation of variables. So the ultimate goal is to get y isolated. So how do we get rid of this dy component? We'll just simply integrate both sides, okay? So integrate the left side and the right side. I can factor out this minus using the constant multiple rule for integrals, so take out that negative. If I find the antiderivative of both sides on the left side, I'll have y squared over 2 plus some constant. Let's call it the constant for the y. On this side, I'm going to have -x squared over 2 plus some constant. Let's call it the constant for the x, okay? All right, so I want to get y isolated. So I'm going to subtract this constant for the y from both sides. And that's going to give me y squared over 2 equals -x squared plus the constant for the x minus the constant for the y. Now this constant for the x minus the constant for the y, we can just call it C1, okay? So minus C of the y. These two, I can just call it C1. And then we can look for what that constant value is. So now we're going to have y squared over 2 equals negative x squared plus some constant c1. Well, why did we call it c1? Well, by combining them together, we can find out what the exact value is. Now, the initial condition would help me determine the value of C1. The initial condition was, if you remember, y0 equals 2. What does this mean? It means that when x is 0, y is what? 2. As simple as that. So I'm going to plug in these two values into this equation, and it will help me find the particular solution that we're looking for in this situation here. All right, so I'm going to plug in 2 for y. So we have 2 squared over 2 equals 0 for x, negative 0 squared plus c1. Okay, all right, let's solve it for that constant, and it'll put it back into our equation. So we have 2 squared is 4 over, looks like I left a 2 out. So there's a 2 right here. There's a 2 right here. Okay, so negative 0 squared over 2. Okay, so if you solve that, you have 4 squared over 2. This becomes 0 equals c1. So c1 is basically 2. Okay? All right. Now, what I'm going to do is I'm going to plug this back into this equation right here and solve for y. So let's go ahead and do that. Plug it back into that equation. Plugging it into this equation right here. So we have y squared over 2 equals negative x squared over 2 plus c1, which is the value of 2. Okay, let's solve this equation for y, and that will be the solution, all right? So we multiply both sides by 2. We'll have y squared equals negative x squared plus 4. And then we can take the square root of both sides. That gives us, and also we can switch this around. Y equals plus or minus the square root of 4 minus x squared. Now what graph is this? This is the graph of a circle. The positive component is the upper semicircle, and the bottom negative component gives you the bottom semicircle, right? So which piece are we going to take? Since we know that y sub 0 is equal to 2, a positive value, we know that the solution to our differential equation, the particular solution under consideration here is the positive piece, y equals 4 minus x squared. So how would the graph of this equation look like? If you graph this, what would it look like? This is a circle of radius 2 centered about the origin. The upper portion of the circle of radius 2 centered about the origin. Isn't that what we have here? This is exactly what we have here. So let's write it. Let's make a connection. The equation of this semicircle is y equals the square root of 4 minus x squared, which is the particular solution that we got right here. So we are in fact confident that our answer is correct. All right? So that's that. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel for updates to other cool calculus clips such as this. Please post a comment to let me know what you think about this clip. Thanks again for watching. More clips can be found on math.sev.com/calculus. Have a wonderful day.